Good morning, everybody. How's everyone doing today? A little louder. There we go. OK. Hi, everyone. My name is Daniel Rosenwasser. I'm the program manager on the TypeScript language, compiler, and language service team at Microsoft. And today I'm here to talk about what's new in TypeScript. Just by a show of hands, who is using TypeScript today? OK. Wow. That's the majority of the room, actually, for those of you who are streaming. But for those of you who are not using TypeScript, maybe you're not as familiar with it. And so let me give you a brief rundown of what TypeScript is. So TypeScript was born out of a basic thing that we saw at Microsoft, which was as we were building more and more code in JavaScript, as we needed to target the web more, our applications we were having a hard time building applications that we could manage at a certain complexity level. And the issue is that over time, as you build code, there are a lot of implicit assumptions in JavaScript. For example, it's not really a problem here in this three-line function, but this origin distance function takes some point object, and presumably it has an x and a y in it, and those both probably need to be numbers, right? But as you build more and more and more code, and most of our code is not just this simple for the most part, you start to hit some problems of actually scaling, and along with other things like implicit coercions and whatnot, we were having a hard time writing JavaScript. And so we asked ourselves what we could do from other languages that would make JavaScript easier to write. And so we added these things called static types. And so TypeScript adds these optional static types. You don't need to actually put them in, but it works better when you do. And so here I've defined a type named point, and all that says is it's an object. This is an object that takes an x and a y, and both of those need to be a number, right? And so the top left here is the type declaration, and the places that I use it are the annotations. And I can run this through the TypeScript compiler, and whenever I do something incorrect, like for example, if I use a property that's not on a point, it can give me a little error message and say, hey, this thing doesn't exist on a point. You need to be a little bit more explicit. And when we tell the computer a couple of other things, right, when we actually can tell it the shape of things, we know where things come from. We can navigate our code more easily, but the computer can also help us navigate more easily. And so if you use an editor with TypeScript support, you can just hover over a variable and see the type. You can see that x is a number. You can jump around your code base, see who's calling a function, where the function is defined, et cetera. And so that's TypeScript in a nutshell. It's an open source, cross-platform superset of JavaScript, right? And really, TypeScript is type JavaScript at any scale. Effectively, if you've already used JavaScript within our editors, we give you some level of support based on TypeScript. And now, if we have some time, I'll get into that in a little bit. But the core idea is we're trying to make it so that you can write type JavaScript no matter if you're writing a very small, simple build script or a very large application. And so the way that we build the product is we have a couple of core values. We try to do open source, but also open development. So we're not just hurling code over a wall. We're actually talking to our users over GitHub. We're on the issue tracker. We're taking PRs all the time. And we're also not trying to diverge from the JavaScript language at all, right? We see it as our goal to build a better type system for JavaScript so that you can get a better editing experience and a better experience writing code. And so diverging from the JavaScript community basically negates the value of doing that in the first place, right? And with that, we can't just keep adding features and making the type system more expressive. Part of the idea is to make it more approachable and to try to grow the community so that we have this virtuous cycle. And so the way that we think about community is through empathy and transparency and open-mindedness. And part of this open-mindedness is often meeting developers where they are. And so a good example of this is a while back, we saw that the thing that was stopping a lot of users of this thing called Babel, this product that allows you to take newer JavaScript code and compile it down to JavaScript code that runs in older browsers. So features from ECMAScript 2015, 2016, 2017, et cetera, things like async functions and classes and whatnot. You can use a tool like Babel to compile your code and run it in an older browser. But TypeScript also does this as well. And so for a while, we were trying to ask ourselves, how do we get Babel users to switch over to TypeScript? Because what they ended up telling us is, I don't want to touch our build script, right? No one knows how it works. Or, I have this CLI that already set up Babel for me, so I don't know how to tear it out and switch over to TypeScript. And really, we kind of reflected for a while, and we came to the realization that, trying to change the tide was not the right move. Instead, TypeScript and Babel could coexist, and we could make TypeScript a choice for Babel users. And so we actually sent pull requests, did the work so that Babel could understand TypeScript syntax, and then basically just rip out the types so that you can use Babel as a compiler or transpiler for your TypeScript code. And that was in development last year. And this past year, Babel 7 was released with TypeScript support. And that actually has enabled a lot of users in the React community using React CLI, Create React App, or the React Native CLI, or even Vue users, for example, as well. So people who were not interested in TypeScript because it was too much setup could finally use TypeScript. And that was a beautiful thing. Another example of this is a little bit more recent. So one of the things that we consistently heard from our users in both Visual Studio and VS Code was that the editing experience is pretty good, but linting, the linting experience in the editor seems to be problematic. And so this came from both TypeScript and JavaScript users, and we see it as our mission to give you a better JavaScript experience as well. And so the two primary linters that the communities use are TSLint, which is a linter for TypeScript, and ESLint, which is probably the de facto linter for JavaScript users nowadays. And, well, we looked at TSLint, and it didn't have the right architecture for speeding things up. Basically, every single rule that you run in TSLint needs its own walk of a source file, of the source file tree. And if you have 200 files and then 20 rules, this gets slow, and it becomes pretty apparent pretty quickly. And meanwhile, ESLint had this more efficient architecture, and we knew that we were not going to be able to actually get JavaScript users to start using TSLint. And meanwhile, we had this very enthusiastic ESLint TypeScript community, people who were trying to get the editor, the linting tooling working with TypeScript. And so we took it upon ourselves to bring the ESLint functionality with TypeScript to parity with TSLint. And so this was a great story because once we actually, went a little, we made this public, made our efforts public. The ESLint and TypeScript communities as a whole actually started moving with us as well. There was a lot of enthusiasm. And this comes back to transparency, right? All we did was tell our users what we were thinking about doing, and people got really excited. So this past January, we published our first 6-month roadmap detailing what features we want to work on, the sorts of things that we want to actually tackle this upcoming 6 months. And this was actually great. We got a lot of good feedback, a lot of people asking, hey, where's my favorite feature, right? But in the next month, we're going to do this again, and we're actually going to take all that feedback and reevaluate it and do the roadmap once more. And this is true of our iteration plans as well. We actually have started taking notes at our planning meetings for every release of TypeScript. And so you can see what things were actually considered, what things we ended up doing, and which things end up getting punted for any specific reason. And I think this has paid off. So I don't know if you all keep an eye on these surveys, but NPM recently took a survey and reported that 62% of those surveyed consider themselves TypeScript users. And 42% of those users are writing TypeScript. So I just want you to think about that for a brief moment. I kind of think of the people who were surveyed here as, there's always like maybe a little bit of bias, but this is perhaps the cutting edge of developers who are early adopters in a lot of cases. And 62% of them consider themselves TypeScript users. More than half of these JavaScript users consider themselves TypeScript users, and that's huge. And we keep hearing these consistent results as well. So in the State of JS survey, year over year, we've been seeing more and more people using TypeScript and more people who are willing to use TypeScript again. And again, this is very humbling because I don't think we ever would have imagined we were here a couple of years ago, right? TypeScript is about 6 years old now, and JavaScript is about 24. And yet we're seeing so much enthusiasm within the TypeScript community. And you can sort of read this chart as 9 in 10 TypeScript users would recommend it, right? It's like we're dentists or something. And the beating drum goes on, right? On the developer survey results of Stack Overflow, we're the 7th most used language and the 3rd most loved, so people just continue to want to use us. But beyond surveys of what people are saying they're doing, we're also able to take a look at what developers are actually doing. So GitHub also runs this Octoverse landscape survey, where they basically look at contribution counts and what languages people are using. And TypeScript has slid into the 7th most used language on GitHub. And that is consistent with actually what we saw in the Stack Overflow developer survey results. But it's the 3rd fastest growing. And definitely typed, which is the heart of the TypeScript community, the thing that actually allows us to integrate with JavaScript, and where we have the most contributors. That's the 10th most active repository on GitHub. And so this is all thanks to everyone here who's using TypeScript, or everyone who is a TypeScript user today. That's the beauty of community, right? Without community, we're just a kind of cool project for adding types to JavaScript. But with community, we're an actual language that people care about and we can do things with. So, we should start talking about, I guess, what's new other than the development of the community as well. So TypeScript 3.0 came out this past year, and this was extremely exciting, and we had a bunch of features packed into that release. But it's hard to just isolate TypeScript 3.0 as this is where all the features went into, right? Because we release on a bi-monthly, half-monthly? I don't know. We release every 2 months, and the point is, every 2 months we come out with great new features. And so I'd like to actually show a couple of those. Does that sound good? Yeah? OK, great. Great. Let's dive into this editor. So I'm going to turn this into onto Light Plus, and I'm going to Can people read the text here? Who cannot read the text here? OK, I'm going to try to zoom in one more time, just so you can in case. So I'm going to write a function called call. And call takes some function fn, and it takes a bunch of arguments. And the thing that it's going to do is it's going to return the result of calling fn with those arguments. So all it's going to do is pass those arguments through. Now, this is pretty innocent-looking JavaScript code, but it turns out that most type systems can't easily describe the behavior that's happening here, right? So let's take like a first approximation. I'm going to scaffold out a couple of different functions, f0, f1, f2, f3, and each of them takes a different number of arguments. And this is our first attempt at typing call. So the first thing that we pass in, we're going to need is a function. So this takes any number of arguments and returns anything. And then it takes any number of arguments, and it just passes them through. And this is OK. So if I call this thing with a string, I'll immediately get an error. So that's some type safety. And let's try to play around with this a little bit. Let's actually try to capture the value that this thing returns. Well, it says that this type is any. So what I actually need to do here is I need to capture the result of this function itself. So I'll introduce a generic type parameter, and basically in those positions, TypeScript will try to infer those to that type. And we don't have to specify the return type. We can actually just hover over here and see that TypeScript is giving us the right return type. Great. So we're a little bit further, right? Well, what if we tried switching this to F1? Well, it still gets the right result type, but it's not actually complaining about the fact that we're not passing in the right number of arguments, right? In fact, I can pass this in. I can pass in a number, and there are no complaints. And so this is very questionable. So we want to try to do a little bit better here. So let's try to add another type parameter. Well, let's say that args is an array of t in both positions. And now we actually get something a little bit closer. We actually see that a number is not assignable to a string. But I can start doing some really more questionable stuff. Like I can start passing in too many parameters, and that's not a problem actually. And even further, I can pass in the wrong parameters entirely if I keep adding more and more parameters. And so the way that most people tackle this is by this thing I like to call death by 1,000 overloads. Basically, you just keep adding overloads for every arity, for every count of arguments that you're going to take. And so you might have seen this if you use languages like C# or Haskell. Like this is just the state of the world. You need to basically statically tell the compiler how many arguments it's going to take at any point. And so indeed this actually works until you say well, let's actually verify that it works. I can pass in their number, and then the error goes away. So this works until you expose this in your API, and then a user says, well, I really needed 6 arguments. Can you give me another overload? And yeah, OK, fine, you can do that too. But the thing is, this gets very annoying, and it's very error prone, right? Every time I write the example here, actually, I keep screwing it up. So we asked ourselves how we could do a little bit better here in TypeScript 3.0. So what we said is we need to be able to try to represent an entire argument list at each of these positions. And so when we infer from one argument list, we need to capture that entire thing and plop it into another place and make sure that whatever functions you pass us actually match up there. So let's write 2 functions, foo and bar. We're good at naming things in programming. OK. And what we want to do here is we want to be able to say that this entire argument list has some type. So we need to be able to represent the same argument list of foo in bar. Well, how do you represent an argument list, a parameter list? It turns out that is mostly just a list of types, right? And inside the implementation, it has to be an array type. Well, we have a thing that's a list of types that's effectively an array type, it turns out. We've had this for years now, and it's called a tuple type. Let's call it my tuple. And this takes a string, and then a number, and then a Boolean. And in TypeScript 3.0, what we decided was, hey, what if you could actually just plop in that tuple type right in this argument list, right in this rest parameter. And so now if I hover over foo, it says x takes a string, and y takes a number, and z takes a Boolean. But when I look at bar, it's saying some argument takes a string, and then the next one takes a number, and then the next one takes a Boolean. And so what happens is whenever you put a tuple in these rest parameters, then it just basically flattens that thing out, and it creates parameters for you. And so that means you actually get the same level of signature help when you're writing things out. And if you pass in the wrong type at some point, like we pass in 42, and then another number, and it says that number is not assignable to Boolean. So this is really nice. Now, it turns out this is close, but when we looked at parameter lists, there are a couple other things that parameter lists do that tuples didn't. So we said, well, in a parameter list, I can actually mark all these things as optional. And we said, well, we can make elements on tuples optional too. So in TypeScript 3.0, we said, hey, what if we could make those optional? And we did. And now you can actually omit as many of the trailing optional parameters as you want when the tuple type has optional elements. And so this is nice, but we also realized that, hey, you've been seeing another parameter type this entire presentation. We had this thing called rest parameters. And so you say that rest has to be of a type Boolean. Well, as you're probably guessing at this point, we said, well, we can do the same thing with tuples. Tuples nowadays they're fixed length. They have, the exact number of elements that you specify. But what if you could specify a tuple with only the first few elements being known, and then you take any number of some type? So in this case, we're able to say that this is a tuple that takes a string. Maybe it has a number. And if it has anything more than that, maybe 0, maybe 1, maybe 1,000. You can pass in as many booleans as you want. And so now we can really bring these things to parity because they have the same arity. So I can just keep passing in as many of these as I want. Now that's cool, I think. But we were originally trying to type call. So let's give this another try. Now that we have the ability to use tuples as first-class types within parameter lists. So we're going to do the same thing that we did. We're going to introduce an R type parameter. But then we're going to introduce another type parameters named A for arguments. And A extends some array type. We don't care what it is. We'll figure it out at inference time. And let's break this to the next line so you can all see. Args is going to take a type called A, right? And we'll put A in both positions. And these two things need to line up, is the idea. And so now, if we take a look at call, still returns the right type. We hover over it. It looks a little gross. But if we actually try to use signature help, we're getting something that's kind of reasonable here, right? It's saying here I take a string and here I take a number. And what happens if I try to pass in too many? Well, it says, hey, you're passing in one too many arguments. And if you pass in too few, you also get an error. And if you mismatch them, right, it just works as you expected, right? Which is the nice part, right? Now, so we succeeded here. But you might say, well, do I run into these functions all the time, right? Like, how common is it to actually write a function that just calls another function? Well, it actually comes up a lot in a lot of asynchronous programming where you're indirectly calling callbacks at a later time. But it's more fundamental than that, right? Because it turns out every function in JavaScript has a couple of methods on them: call, bind, and apply. And basically, if I jump to the definition of call, before more recent versions of TypeScript, we just had this very loose call function. It took some function. It took something for this. That's a little bit more than what we were working with. And then it takes any number of arguments and then returns any. So it's very similar to what we started with. But that's very lax. So with TypeScript, more recent versions of TypeScript, we actually introduced a new flag called strict bind call apply. And so now if I jump to the definition here, it gives me a more precise version of this call method. And the reason for that is because we didn't want to introduce a breaking change without a strictness flag here. So now it actually does a very similar thing to what we did. It takes some arguments, that extends any, takes the result type, and then funnels along the result type and the arguments. So if I just pass this in, this is a little bit different because it takes this argument. But if I pass in the wrong arguments, it gives me a reasonable error message. If I pass in the right ones, everything just works. And so we're not just doing cool features because we think that they're important to type in this one niche scenario. This is stuff that is supposed to be broadly applicable. And we want it to be able to generalize across different patterns as well. Another thing that we started thinking about once we did this was transforming each of the elements of a tuple type. So I'm going to jump a little bit back in time to show you just a quick thing. Let's go to a light theme. I like dark theme. So what if we wanted to be able to do things on argument lists right after transforming each of the elements in the argument list? So this is sort of this uniform transformation, I call it, right? You basically take a type and you do the same thing with each of the element types. And we have something like that in TypeScript, and it's called a mapped object type. And so I can, just to show you an example, I'm going to write one up here, and it's called optionalize, and it takes some type T. And what's going to do is iterate over each of the properties in T, and it's going to basically fetch the original property type out. So we'll say that fetch the property K inside of the original type T. And so basically this duplicates it, but the thing it's going to do is it's going to mark each of these things as optional. And so now I can say I have a partial person, which is an optionalized person. And if we hover over this, it's basically identical to the person type, right? We just took the name element and we said it was optional, age is optional, location is optional, right? But we could be very flexible about this. We could actually say that each of these element types are promises of the original type. And instead of optionalize, we'd call this promisify or something. And if we'd write promisey person, just so we're consistent. So now we have a name that's a promise of string and an age that's a promise of number, et cetera, right? What if we wanted to do this with a tuple type? Right? What if I wanted to be able to say that I have a number, a string, and a Boolean, and I want each of these to be a promise of string, promise of number, promise of Boolean? Well, if I hover over this type now, that's not what I get, and I don't think it's what you want. Like, you probably don't want this. I'm gonna go out on a limb and say that. It gets close to what you want, right? It maps each of the numeric properties of the tuple, right? So at 0th position, you get a promise of number. At the next one, you get a promise of string. But then you get some questionable stuff, right? Like length is a promise of 3, which, I mean, I use that all the time, but probably not most of you do. And then you get the includes method, and so you have a promise of this function that I don't know. I can't even read this at this point. And so people would often try to run array types and tuple types through map types, but they'd get the wrong result most of the time, and this was very unexpected. So what I can do here is, fast forward in time. That was TypeScript 2.8 that I was running in. So what I can do here is I can plug this through. It's not really a promise person anymore. We hover over this, and we actually get the right type. So in newer versions of TypeScript, each of the element types in the tuple is actually mapped, right? And it's not just tuples, it's actually any array type. So if I say that I have an array of number, then it's going to give me an array of number promises, effectively. It's a little bit hard to read in that order. But basically, this is very handy because we didn't have to introduce a new concept. You can just reuse your map type logic in a lot of these cases. So why does this matter, right? That's always the question. Well, it turns out we have this function built into our standard library, or into JavaScript runtimes nowadays, called promise.all. But the way that TypeScript types promise.all, well, maybe you've heard of this expression. It's called death by 1,000 overloads. So it does the thing that you expect it to do. It takes each of these and it finds an overload for each of these things. And it goes up to 10. And if you get 11, I mean, sorry. But it currently doesn't do it today. But we could make something that actually does work as you might expect. So let's write our own promise.all. So let's scaffold it out. We have a string promise. We have a number promise. And we have an untyped promise.all. And the idea is that this should take an array type and basically give us a promise of the list of each element type, right? So it waits for each of these things and then gives you a promise of that. Well, right now it returns any, and that's actually the issue. So what we can do now is we can use a little bit of inference magic here. So you can take some t that extends any array. And what we're going to do is instead of trying to unpromisify each of the elements, we're going to use a very declarative form. We're going to say that, we're going to call it P's. We're going to say that P's extends this t type, or sorry, promisified t. And basically, when we get a type here, we'll try to reverse infer from a promise of IT to the T type, and then we'll end up with a promise of T itself. And so now if we look here, we end up with a promise of a string or number array. And so that's actually pretty close to what we wanted here, right? I can write an async function foo, and I can say let x or blah equal await x. And now with blah, I have an array. I can index into it. And if I hover over this thing, the issue is that I get a string or a number. And the reason for that is because the inference process basically assumes that you want something that you can mutate. So for example, I should be able to actually push another element into this array. Push. Jeez, what's wrong with me today? I can actually modify the array. So it takes mutability into account. But what I'd really like to do is to be able to say that this thing needs to maintain each of the indices. It needs to maintain the types at each position. So what I can do here is I can use this new thing called asConst. And right now it yells at me and it says, well, you're giving me something that's read-only, but you're trying to assign it to a mutable type. So that's not an error in the demo. This is actually something that I need to account for. Right now, promise all effectively expects what it says is that it takes an array type, but it doesn't make any guarantees. It implies that it could actually be modified. So what we want to do is we want to say that we have a read-only array of any. It extends a read-only array of any. So what did I just do there? Let's try to extract this out to its own constants. If we hover over this thing, it tells us that we have a read-only tuple of a promise of string and a promise of number. And so this asConst assertion effectively says we are in a position where we want to only think about things as immutable. We're actually taking immutable data structures as, well, we're taking first-class JavaScript data structures, but trying to give them a way to be described as immutable in a first-class manner, right? And so now I can actually say that this thing takes a read-only array, and when I look at this, I actually get a string. And so I can do things that strings can do, right? I can do to lowercase. That's my favorite method on strings, I guess. And I can take the one at the first position, and then it's an error because that's a number. And then if I can take it at the second position, it tells me, well, you're going too far in the array. And so, we really took immutable styles of programming in JavaScript and TypeScript pretty seriously in the last couple of releases, right? In the 3.x series, we started thinking a lot about function composition and immutable data structures. And this comes up a lot in JavaScript nowadays. And so we even added a new syntax that you can use. So you can instead of read-only array, you can say read-only array of the thing that you've got, right? And so this makes it a little bit more, a little bit easier to express the things that we want to do here. So that's a couple of the things that we've done in the last couple of releases over the last year. The correspondence between tuples and parameter lists, easier functional programming patterns. I wish I could dive even further in, but I don't, we just don't have enough time. But then one other thing that we started working on is we started thinking about how we can give you faster project builds. So, there's this certain style of coding where you can basically set it up as, you can basically start up a pretty small TypeScript program, and it's very self-contained, and you have no issues, and you just, every time you need to make a change, you recompile, right? And then you can think of organizing your code in terms of basically separate packages on NPM, potentially. But there's something in between these things, which is what a lot of people tend to call a monorepo. And that just means I put all my projects in the same folder. It's not, it sounds scary, but it's pretty common. And the most common monorepo setup that we end up seeing is, this is the simplest one probably. You've got a front end and a back end. You have client and server code, and each of those has tests respectively. And then you have this shared code base that each of them uses. So you might have types, you might have validation logic, things like that, right? And the thing is that previously it was the case that if you wanted to recompile a client, it would just suck in shared and try to recompile all of that. And so you were doing a lot of wasted effort. And there were just issues with the way that everything was emitted. So your output directory would be cluttered. And so we introduced this thing called project references so that you could make these logical boundaries between each of your projects. And so you can actually say that whenever shared is affected and it has a downstream effect, then you need to recompile the client and the server. And if the client and the server don't have any downstream effects in their API boundaries, you don't have to recompile your test and a subsequent build. And so, assuming each of these is equally as large, right? All your tests are as large as your application code, right? Then you're basically able to, in this scenario, cut out 40% of your build time in theory, right? And so project references in TypeScript's build mode allows you to really cut down on wasted builds. So for example, if I actually just affect one line in my shared directory, and I really didn't affect the API, right? I just added a comment. I shouldn't need to do a full rebuild of the client and the server and everything else. So in this scenario, client and server aren't affected. They basically, none of their assumptions have been invalidated since the last time. So we implemented build mode, and that understood project references in TypeScript 3.0. But that was the minimum viable product, right? We had watch mode and things like that. But we also had a watch mode that was built into the regular TypeScript compiler, right? Just for any other regular project that didn't use project references. And whenever you have, whenever you're running in watch mode with the TypeScript compiler, it actually does this file level incremental rebuild whenever you touch a file. And so it actually does the same sort of logic, right? It figures out which files have been affected, and whichever ones need to be rebuilt need to get rebuilt. And that way, as you hit save, like we're able to really just almost instantaneously do a re-emit and a recheck in a lot of cases. And the build mode was not using that. So the logical next step was to make it even faster, right? Because no one, well, I mean, I like my coffee breaks, but no one likes long build times. So we were able to implement that. This is a weird diagram, but we were able to implement that file level incremental watch within build mode. But then there was just still this question of like, well, I still want faster cold builds, right? Because build mode is all about being able to look at the state of the world since you last compiled, see what needs to be recompiled, see which projects are affected. And, well, you're not able to give me that at the file level, right? I still want to do that at the file level. And so we said, what if we could make it faster, builds faster for everybody, whether you're using build, whether you're using regular compiles with TSC, but just saving the state of watch mode since we last ran. And so we take all of your compiler options, we take the project graph, we'd figure out how we even got the state of the world, and we put it into this new file called tsbuildinfo when you're running with this new flag called incremental. And incremental is kind of a dream, because if I show you what the VS Code team was dealing with before, if you look at what a compilation with incremental was, just a cold compile, that's about 47 seconds. Now, if you turn on incremental and do your first compile on a repo, that's about 52. And that's still pretty bad, right? I don't know how the VS Code team keeps generating such great features, but somehow they deal with this, right? And it's probably because they're able to get fast checking in the editor. But with incremental, right, if I make a change that affects a lot of files, that goes down to 30 seconds on a subsequent build, right? Because it's able to look at that tsbuildinfo file and see what was the state of the world, what do I need to recheck, what's been affected, and then you're basically done. So you're able to cut out 22 seconds of a build. But even better than that, if you're just making a very minor change that's pretty isolated, that just goes down to 12 seconds. So we can cut down build times by 80 seconds in some of these cases. And that's just the beauty of it. And so if you're not using incremental today, I would highly recommend that you upgrade to the latest version of TypeScript. Give it a try. Nobody doesn't like fast builds. Everyone loves fast builds. So One last thing I want to talk to you all about is, well, not last thing, one more thing. One more thing I want to talk to you all about is productivity and tooling. So the TypeScript compiler is not just about, it's not just about, the language and the checker and all that. It's actually about the editing experience. As you saw when I was up here, I was able to write a bunch of code. I was getting signature help. I was able to jump to definition of things and find all the references of these things as well. And the TypeScript compiler is the core component that actually powers all of those things. We actually build this language service that provides all of the information that an editor needs to power these experiences. So if you're using VS or VS Code or Sublime or whatever, TypeScript is actually the heart of that. So just wanted to show you a couple of the new productivity features that we were able to work on for the last year or so. So maybe a couple of you have seen this before. But if you're running in, let's say strict true, we're able to do this thing where, hey, we can tell you when your parameters and other variables are implicitly any. And any is not great because, well, it lets you do anything, and it's a source of unsafety. So we added a quick fix for this so that we could infer the types from the usage, right? But something that's a little bit more subtle than that is when we turn strict off, we don't like to see all of these red squigglies because it makes it a little bit overwhelming to migrate to a stricter mode in TypeScript. What we're now seeing, though, is that there are these 3 gray dots. I'm not sure if you all see them, but that's a suggestion diagnostic. So instead of a full-blown error, we're able to actually tell you, hey, this thing actually has the type any. You might want to add a type annotation. And so what we can do there is we can actually still respond to these things. And now people who want to be able to incrementally migrate to the stricter modes in TypeScript can do so in a feasible way without feeling like you're drowning in a sea of red squiggles, right? And that's really nice. And then we can play a little bit more with this sample, right? So for example, let's say I'm looking at this function greet here. I take a look at each of these parameters, and I can kind of guess what they do. But if I'm very far away from the declaration, I don't want to have to jump to it or hover over it. And maybe I want to reorder these for some reason or another. Well, in one of our recent versions, we had our intern Gabriella work on this really handy refactoring to make it look like you're using something like named parameters. Now, JavaScript doesn't have named parameters, but we can apply this refactoring to turn these parameters into a destructured object, right? And now I actually know which parameter corresponds to what. So I can take this and I can move it over. Whoops. I can move it over to this position here, and that's handy because for really long object types, we often have these option bags in JavaScript. Once you start to see that you've got maybe 4, 5, 6, 7 parameters, it might be time to reorder them so that it's more obvious what your function is doing. And so, I'm using this function. Maybe I want to move it to a new file as well. So that's another new refactoring that we started to add. So now, I guess I have a greet existing already. Whoops. Well, I can jump to greet 1, and now I can see that I don't have to think about what dependencies does this depend on? How do I put them all in this other file here? And if I want, I can call this phrases instead of greeting. And now I'm getting another thing that says, hey, I saw that you renamed phrases. Do you want to update the paths? Sure, I'd love to. And so now the path is updated. But I don't really like to leave my editor. I really like to stay in the buffer. So I can rename this my phrases from here as well. And so basically we're trying to make it so that you can easily just move code around without having to think too much about it. And you just don't need to make as many context switches as you otherwise would. That's what makes you code faster and happier. So those are just a couple of the refactorings that we've done and the productivity features that are built into the editor. And the last thing I want to talk about is UX and approachability. So last year, we made a trip to a couple of companies everywhere, but there was one trip in the Bay Area where we got a lot of different feedback from places saying like, oh, could you add this feature, could you add that feature? But the thing that we consistently heard from every company was, man, your error messages get so bad sometimes. And you know, we're adding good features, but sometimes they admittedly do get a little bit out of hand. And you know, some people are trying to break records, and you know, hey, if you like to compete on this, I encourage you. But we really didn't like this, right? Like, this is a fairly small example, but it triggers this very nasty thing. And the thing that we heard from these companies was we often have new people coming in. They've never dealt with another typed language at all, or maybe JavaScript is their only language that they know. And the learning curve of TypeScript ends up being very scary because of this. And so we worked on this, and we started thinking and working with other, with the editor teams of how we could display the information that we want to better. And so we cleaned this up dramatically, where we were able to just, for example, you no longer have the error span on the entire object literal. We can tell you the thing that, the place that the error is occurring. And then we can cut out all of the, that entire huge stack trace, that pyramid of doom sort of thing. And we can also even tell you, hey, this thing was declared here. Do you want to jump over to this as well? And that sort of thing makes it easier and more approachable because, I mean, do you want to read this entire thing? No, right? And so between 2.8 and 3.0, we started making these huge leaps, right? And it was great because, the same sorts of things, depending on whether you're using object literals or even, for example, JSX, it didn't matter. We were able to just make the entire experience nice. And we were proud of that. And we're committed to that as well. So we've been working on the last couple of versions thinking about, hey, how can we do a little bit better? And it's not just us either. The community has been pretty amazing about sending us pull requests. And in fact, anyone here should feel free to send a pull request for anything marked as error messages and good first issue on our issue tracker as well. And one other last thing was I want to talk about the documentation on our website. So over the years, a project starts to kind of get a better idea of what the targets that it has are and what its goals are. And one of the things that we heard from people was, the TypeScript handbook makes a lot of assumptions. It makes assumptions that I already know another language. It makes assumptions that I know C#. It makes assumptions that I'm using OO patterns and things like that. And while we want to be inclusive to everyone who's already in that group, we actually want to broaden what we're trying to do. And so we've been working on a new handbook. And so the real treat is, the content. The things that we're trying to focus on are, for example, union types are one of the first things that we end up covering. And so you don't feel like that's an advanced type, so to speak, right? That's actually the bread and butter of what TypeScript is. So narrowing, for example, is the third chapter in the new handbook. But we're really taking documentation seriously as a first-class citizen. So for example, you're seeing this little red squiggle. And the thing is that this is not just any red squiggle that we did on our own. This is actually generated from the TypeScript compiler. So every single example in this handbook is validated, and error messages are one-to-one with what TypeScript would give you. And this is good because it's not something that is unexpected when you see a difference between your documentation and your editor. But it also keeps us honest. So if we ever see a bad error message, we can actually take a look at that and say, no beginner would ever want to see that. We need to fix that right now, right? So it gives us a little bit of priority. And we can actually make documentation using everything that your editor has. So for example, when I'm writing this, I don't have to write the type here is a string and the type here is a number. I can actually just point to any of these locations, and this is exactly what your editor would display if you were working with it with TypeScript. And that's actually kind of a beautiful thing. And of course, one thing to show off is dark mode, right? So we're actually thinking about dark mode and different theming so that if you're reading this stuff late at night, I know these are big transitions for your eyes, sorry. But as you're reading these things, we want you to feel comfortable. We want to make this as fast as possible. And so, this runs with as little, this is ironic, it runs with as little JavaScript as possible. It's all rendered once with our compiler. And we're hoping that this is an experience that comes by, November of this upcoming year. We should be done, and we should have something ready for all of you. So with that, we have about 10 minutes left. And what I'd like to do is open up the floor to a Q&A. And we have the pleasure of Anders Heilsberg. He'll come up as well. If you all want to applause as well, yeah. So I guess we'll do a joint Q&A. Yeah. Do we want to open up the floor? Any questions? That microphone is right there.
Yeah, so I was kind of curious about WebAssembly, and if there is, I knew you were going to get this, so. I just saw assembly script for the first time.
Right.
We know it's going to become a bigger thing in the future, and I'm just wondering if that's going to be a target.
So let me talk a little. It's funny, the first question is always WebAssembly. So I've said it before, and I'll say it again. I think WebAssembly is the most incredibly aptly named technology, and on the web today, everyone wants assembly because it implies faster, right? But it's also in many ways misunderstood, and I'm not implying that you're misunderstanding what it is, but something like assembly script, for example, takes this TypeScript syntax, but it doesn't take any of the semantics at all. So it's a different language. It has nothing to do with TypeScript, really. And if you think about what has to happen if we compile to WebAssembly, well, in order to compile TypeScript to WebAssembly, TypeScript is a superset of JavaScript. In order to execute that in WebAssembly, you have to include a full JavaScript VM inside your JavaScript VM. This is getting very meta. But WebAssembly is really the ability to run a low-level machine code inside your browser in a sandbox, right? But anything you want to run, you have to include yourself. And that means we would have to package a complete JavaScript VM along with the code if you wanted to preserve the semantics, or we would have to define a different language, and now it's no longer TypeScript. So WebAssembly, in my mind, is really suited for if you have some C code that you want to compile, say with mscripten or whatever, a game, a compute engine, or whatever, you want to compile it into machine code. And then you want to call it from JavaScript and get the result back and have the computation go faster. But you're not having that piece of code in there called JavaScript APIs or anything like that. That's really sort of the level that WebAssembly is at today. Now, WebAssembly is going to evolve, and the cost of transition in and out of the sandbox is going to get lower and whatever, and we'll see where it goes. But so far, if you want to run JavaScript or TypeScript in a browser, you already have a fantastic VM built into the browser, and it makes much more sense to use that. So for TypeScript to target WebAssembly simply isn't meaningful.
This is actually why I brought Anders, because he has this entire response pre-canned, right?
Now go sit down.
Yeah,
awesome. Thank you so much.
Yeah. But I think it does help to think about it Socratically in that way.
Yeah.
All right, how's it going? So I know we have the reflect metadata API, and I was wondering, is there going to be sort of progress on runtime reflection? So maybe a little bit more specifically, being able to look at a method and see the arguments when they're specified as interfaces. So,
well, I think there's a couple of things there. I don't think that we see interfaces compiling down to anything anytime soon, right? Basically, the entire premise is that these things get erased away, and so that way you can easily overlay TypeScript without affecting the JavaScript semantics. Now, that is something that we've heard a lot of demand for a while, but I don't think it's anywhere in the near future for that direction at this point. Yeah. Sorry about that.
Cool. Yeah, no problem. Thank you.
My question is about private variable syntax. I noticed in the new ECMAScript there's syntax that looks different than TypeScript private variable syntax. So I was curious about the plans for the future there.
Yeah, there is a proposal to use the pound sign or number sign in front of an identifier to designate private variables. The proposal currently, is it at stage 2 or is it at stage 3?
I think it moved to stage 3.
It moved to stage 3.
And Chrome has it implemented now.
Chrome has it implemented, but it is not officially in the ECMAScript standard, and we're weighing whether to go there or not. It's not clear whether it's going to make it all the way through. I mean, so
Yeah,
we'll see. I mean, our concern here is we don't want to put features into language that we then later have to retract.
Yes.
Is basically it. There's already actually an implementation of private variables, a pull request implemented by Bloomberg that we're considering merging, but
we've been working with them for the last 6 months to make sure that, you know, as it goes through ECMAScript, it's in a ready state for us to pull in, and so that actually has looked pretty good so far, and so the two of those things, you know, one thing that people often ask is whether or not TypeScript's private fields or private properties are going to be compatible with the private fields proposal. And the way that you can sort of think about it is that they really are orthogonal, right? They don't actually affect each other. Private fields are inherently design time private, and so you never really have to think about whether or not, you know, you toggle the public or private modifiers on them. But then you can think of TypeScript's public, private, and protected as really just types overlaid on the type system, right? And so those just like anything else in the type system, they're supposed to be things that we can erase away easily. And so,
but certainly, you know, if the ECMAScript private fields proposal makes it to stage 4 and looks certain to go in, then we will absolutely pull the trigger and support it in TypeScript 2. We just want to be cautious because we have features today that are legacy that we're having to maintain, like our decorators that are incompatible with the other decorators that then in turn didn't make it into JavaScript, and so it's like, you know, there we are. And we just don't want to do that again.
Thank you.
You're welcome.
Hi. The rework documentation you showed at the end looks awesome. Any chance of it including some beefed up documentation for the compiler APIs?
So I guess as the person who wrote the compiler API examples, I should answer to that. You know, I don't necessarily think that the audience for the compiler API is the same group of people going through the handbook.
Right.
However, you're not the first person who's brought this up, and I think it's something we should strongly consider once we have some time after the new handbook goes out. Okay. So if you actually have examples of things that you'd like to see, the wiki itself is its own GitHub repository, and so you can send pull requests, you can file issues and tag me in them, and we can try to consider that, because I think the examples are often the most telling ways of, you know, they can actually help you understand the internals better.
Okay.
Does that sound reasonable?
Yeah, sounds good. Thank you.
Awesome. Thanks.
All right, so is this capturing decorators, arrow functions, or binding?
What about decorator arrow function binding?
No, like capturing this, what's your preference between decorators, arrow functions, or using bindings?
Personally, I would recommend you in any function where you want to be assured that you've captured the actual this, I would write it as a lambda as an arrow function, and then just assign it to a property of your object. At that point, you know that you have statically captured or permanently captured the outer this in that function object. And it doesn't matter how that thing is called, you will always see the correct this inside your arrow function. So that in my mind, it's always the one and only sort of absolute certainty way to capture an outer this.
Yeah, I definitely agree with that. And when you use all of our strictness flags, we specifically have ones for capturing this, and those are really handy, right? So arrow functions with those combined really help avoid the problems with this in JavaScript that you end up running into a lot. Any other questions?
Out of time.
2 seconds, 3 seconds? Oh, okay. So, all right. Thank you all very much. And thank you.